The MOSFET bias circuit is shown, we're asked what is the current source, IS, in milliamps. So this is what we're going to be finding. We can assume the transistor is in saturation region and use the following equations here. Also, this right here. We can neglect the effect of channel length modulation and body effect. So if you want to learn more about this, there's more examples and more notes in the playlist and in the link, the Google Docs, in the description below the like button. But for this problem, if we run through it, we're going to solve for this I of S right here. And we will know that this I of S is simply equal to the voltage source minus the voltage at the endpoint over the resistance that is happening. Now the endpoint is ground, right? It's going to be this right here. So that means essentially we have I of S is equal to some voltage source, Vs, over our 9.9 kilo ohms. Now, to solve for this, we need to solve for our V of S. And what is our V of S? Our V of S is going to be set equal to, and when we do this, let's use the node voltage method. So we are going to have nodes at this particular spot right here. Our V of S is going to be equal to, we know our ID going in, we're going to have some voltage going out, and we have our I of S going out. So the voltage source, we can write it as all the voltages going out are positive, so Vs plus Vg minus our Vd is equal to 0. If we rewrite this to solve for our Vs, it's going to be equal to a Vd minus a Vg. And looking at this, we need to find what these Vd and Vg are. Well, Vg is pretty simple. It's going to be VGS for this, our gate source. And our gate source is going to be equal to, if we look up here, our VOV plus our VT. And our VOV is 0.2 plus our VT, which is 0.6. So we're going to have a 0.8 here. Next, we need to solve for our VD. And our VD, what we can do is use the voltage division that's happening here. We see that we have this VDD right here. We have our VD, and then we have these resistors that are with our ground. So when we solve for this, our source is going to be like this. We have a VDD, that's long here. Then we have this resistor, RG1, and then we have another resistor, which is going to be our RG2. And it's going to be connected with our RD when we rewrite it. So our RD is going to go here. All this is going to be linked where it goes to ground. So writing this out, we want the voltage that we're solving for, Vd, set equal to our source voltage, all happening over our RG2, over our RG2 plus our RG1, and that is just the voltage division, just general equation. After we plug this into a calculator, we are going to get approximately 6.8, and then subtracting these two, we are going to get that our V of S is equal to approximately 6. So we did like this step first, then we did this step, and then we did this step, and that concludes us at this step. So with our V of S about 6, all we need to do is plug it back into our original equation. So 6 goes here, and then dividing this out, 0.6, and this is in a milliamps because we had kilo ohms on the bottom, so when we convert it, it's going to be in milliamps. That's how we go about solving this problem, looking at it, and doing anything like it.